Hello students, we are going to study factors affecting acidic strength. When we talk about the acidic strength, it means what? If it is dissociated easily, if any molecule is dissociated easily, naturally it is a strong acid. So if we talk about this dissociation, extent of dissociation depends upon the strength and the polarity. Okay, so of what? The polarity of that acid and the strength of that acid. Okay, so if the strength of the bond here, if we are seeing, it is less. Okay, if it is less, naturally what will happen? Energy required to break this bond will be less, and if it is less, naturally it will be dissociated easily and it is a strong acid. Okay, and yes, if the strength of the bond is high, naturally the energy required to break that bond will be high, and that will not be a strong acid, it will be a weak acid. Okay, now if the polarity is more of this HA molecule, okay, what happens here? If the polarity is more, it means what? The electron negativity value is more. Okay, if we talk about, for example, Hi, okay, polarity is more. Okay, naturally what will happen in this? Electron negativity value is also more. Naturally what will happen? It can break easily, and if it can break easily, it will be more acidic in nature or stronger acid. Okay, you can take example of beer also over here. Electron negativity difference is more. As the result, what will happen? It can cleave easily and it will be a stronger acid. Okay, now next. Okay, now same group, if we are seeing in the same group elements, okay, we have to see what? The size. Okay, so if the size is more, acidity will be more. How come? For example, if we are taking this 17 group, all the halogen acids, okay, here HF, HCl, HBr and HI, we see what? The size of fluorine, chlorine and bromine and iodine, it is increasing, isn't it? So here when the size is increasing, acidity will be more. Why? If we talk about HI molecule, the size of iodine is too much rather than when we compare it with bromine, chlorine and fluorine. And as the result, if the size is much, to cleave the bond it becomes easy. If we talk about here polarity is too much, HF and H and F. Okay, the polarity of fluorine, because fluorine is very electronegative in nature, isn't it? And most electronegative element. But then also the acidity will be of HI will be more. Why? Because here size of this iodine is more. Here as the size is less, what happened? There will be a strong bond if we are talking about the acids of the same group elements. Okay, so here we will be seeing what? The least acidic will be HF, then HCl and then HBr, and HI will be the most acidic one. Okay, and this is shear dependent upon the size of the element with which it is joined. Okay, now coming to the same period element. Okay, now group we have studied, now we are studying about the same period element. In this, if the electron negativity increases, okay, what happens? Its acidity also increases. For example, we have taken CH4, NH3, H2O and HF. Okay, here we are going along a period, isn't it? So here we are seeing what? This acidity is increasing in this case of what? The period. Because here what happens? This F is more electron negative, isn't it? Electronegative, then oxygen it is bit less than that, then nitrogen is bit less than that, and this carbon is the least. Okay, so when in the same period element, when the electron negativity increases, the acidity also increases. So now we are going to study common ion effect in ionization of acids and bases. Okay, so here if we are saying about common ion effect, it means some ions are common in nature. So let us see how it is. Okay, it is based actually on the principle of Leach and Pierce principle. Okay, and it says that yes, shift in equilibrium on adding a substance that provides more ionic species already present in the dissociation equilibrium. Okay, it means what? Here, if in a reaction, okay, the products are being formed, it is in the equilibrium position. If we add any of the components in excess, what do we see? We see a shift in the reaction. How? Let us take an example. Okay, if we have taken what? Acid like CH3COH. Okay, what is this? This is acetic acid. Okay, and yes, it gets partially ionized and it is in equilibrium position, forming what? H plus ions and acetate ions, that is CH3CO minus ions. Okay, so now what we are doing? We are just adding an excess of acetate ions in this. Okay, that is what? CH3COO minus. Okay, if we are adding this acetate ions in excess, what do we see? Will the reaction be in this position? No. Why? Because the concentration of acetate ions increases, which shifts the reaction in backward direction. Okay, now why this happens? Because when this increases, the concentration of H plus ions here decreases. Okay, and when the concentration of H plus ion decreases, naturally the reaction moves towards the backward direction. Okay, second case if we take, here also what? Acetic acid is being partially ionized to H plus ions plus acetate ions, that is CH3COO minus. Okay, now what we are doing? Instead of adding acetate ions in excess, what is being added in excess? H plus ions. Okay, so when we add H plus ions, what happens? This becomes in excess in the product side. Now here the concentration of acetate ions is decreasing. Again an imbalance. Okay, so in order to counterbalance that imbalance, it will move towards the backward direction. This only Lee-Chatelier's principle says. Okay, if there is any change in the concentration and other factors, what happens? The reaction tries to stabilize itself and tries to counter effect that change, and in that manner only the reaction, the shift in the reaction takes place. Okay, so here we are seeing what? With H plus ions more and acetate ions less, what happened? It moves towards the reaction shifts towards the backward direction, and this is the common ion effect. It means yes, if we are adding any of that ion only, same ion, and if the concentration is being increased, what happens to the ionization of the acids and bases? And that is only what? The common ion effect in the ionization of acids and bases. So we are going to study hydrolysis of salts and the pH of this solution. Okay, so how are salt formed? They are formed by the neutralization reaction of acid and base, you all know. Here we will be seeing the reaction between a weak acid and a strong base, a strong acid and a weak base, as well as a weak acid and a strong base to form what? The salts. Okay, so here actually these acids and bases, okay, they combine in the definite proportion, okay, to form what? The salts. Okay, and these salts gets ionized in water, and that is known as what? Hydrolysis of salts. Okay, now so for the hydrolysis of the salts, okay, we have taken what? A weak acid and a strong base. Okay, the product, for example, it has formed what? The sodium acetate. How has it been formed? This sodium acetate, we have taken a weak acid. Weak acid can be what? CH3COOH, weak acid. Okay, strong base we are saying. What can we take for making this? NaOH. So we will be getting what? Sodium acetate, that is CH3COONa. Okay, now next we take another, that is a strong acid and a weak base. So what strong acid we can take over here? We can take over here what? A strong acid, HCl we can take. Okay, and we have taken what? NH4OH, that is a weak base. We will be getting what? Ammonium chloride salt. Okay, third condition is we are taking a weak acid and we are taking a weak base. Okay, so weak acid we can write CH3COOH, and a weak base we can write NH4, okay, OH. So we are getting what? Ammonium acetate salts. Okay, so three conditions we are seen from which we are getting these different salts. Okay, so now in order to calculate the pH, there is a formula 7 plus half pKa minus pKb in the bracket. Okay, no need to go in detail for this formula. Okay, just learn this formula over here. That is to take out the pH of these salts. The formula is 7 plus half pKa minus pKb. Okay, in brackets. So here, if we are seeing the difference is coming in a positive sign, it means what? The pH is greater than 7, and when the pH is greater than 7, it means it is what? Basic in nature. Okay, that salt will be basic in nature. Now, but if the difference comes in the negative sign, okay, it means the pH is less than 7, and if the pH is less than 7, then it is acidic in nature. Okay, so for example, I will show you with the example. Suppose here pKa value, okay, of acetic acid is 4.76, okay, and pKb value of this ammonium hydroxide is 4.75, okay. So now putting it in the formula of this pH is equal to 7 plus half in the bracket pKa minus pKb, okay. So we are taking out, and we want to take out the pH, okay. So of this what? The salt formed by these two, that is what? Ammonium acetate. So we will be putting the value 7, okay, plus half. pKa value we are having 4.76 minus pKb value we are having 4.75, okay. So now what will be the difference here? It will be what? 0.01, isn't it? So now just simplifying it, okay, and then adding it with 7, we are getting the value how much? 7.005. So here what is this in this? What is the pH of this salt? It is 7.005. The pH of this ammonium acetate is how much? 7.005. This is how we can take out the pH of the salt. So, think so you might have understood it. Okay, numericals we'll be doing at last in a totally complete section of the numericals. Okay, so good day, take care.